Hello class, this is lesson 4-1, so we're starting chapter 4 in our textbook, and it's all about how to write linear equations in slope-intercept form. This is a form that we dealt with already last chapter, and so now when we're looking at the slope-intercept form, y equals mx plus b, if you're asked to write an equation, you only need two things. You need to find the slope, and all you need is the y-intercept. This is going to be so easy. When you find those two things, plug them into this form, and I have an equation. So let's look at our first example. It says, write an equation of a line that has a slope of -2 and a y-intercept of 5. Do I have my slope? Yes, I do. Do I have my y-intercept? Yes, I do. Let's plug them in. Y equals the slope, which is -2, and then I'm going to put my x, and then I'm going to add on the y-intercept. Here it is +5, so I'm going to add 5, and I'm done. If you have a problem like that, you shouldn't actually have a problem with it. It should be very simple for you to put into slope-intercept form. They're not always going to be that easy. You might be given a graph, okay? Right here, it's actually a yellow line, and maybe I'll make that a little bit clearer for you, what point it's trying to show on the line. And it says to write an equation of the line represented by this graph, okay? This is really, really easy to do, right? Immediately I can look to see where my line is crossing the y-intercept. And it looks like it's crossing at +3. So the y-intercept equals 3. And then just by looking, I can figure out what the slope is by finding out what the rise and the run would be just from one point to another. So looking here, I'm rising, actually I'm falling -2. And then I'm going to run to the right +5. So this means that my slope is -2/5, or -2/5. So when I combine those, y equals the slope, which is -2/5, add on my x, plus the y-intercept, which is 3. And I'm done. You guys are going to love this section. All right, let's move on. If you know where the line crosses the y-axis and any other point, you can write the equation. Okay? So here's an example. I have a graph, okay? And I know where it's crossing the y-axis, and I have two other points. Okay, so instead of me just counting the slope, the rise over the run like I did in the last example, why don't we actually calculate the slope? So if we recall, the equation would be m is equal to y2 minus y1 divided by x2 minus x1. So in this case, maybe I'm going to start with -5. So -5 minus -1 on the top. And the bottom would be 0 minus 3. So this is really the same as -5 plus 1, which is -4. And the bottom, 0 minus 3, is -3. Well, those negatives are going to cancel out, so your slope is going to be +4/3. And then I can also see right here where it's crossing the y-axis. So the y-intercept is -5. When I put those together, y equals the slope, which is 4/3, x, and then I'm going to add on the y-intercept, so -5. And I'm done. Let's do one more just like this. Move this up for you. So let's write an equation that matches this graph. So again, let's calculate the slope. Okay. And this time the 2 points that I'm given are 0, 4, and also 2, -4. So I'm going to find the y2 minus y1 divided by the x2 minus x1. I'm going to start with maybe the top one this time. So 4 minus -4 all over 0 minus 2. 4 minus -4 is the same as 4 plus 4. So I have 8 on the top, and 0 minus 2 is -2. When I divide those, I get -4 for my slope. And then if I'm looking for the y-intercept, I can see that clearly it's crossing the y-axis at positive 4. So ever if you have a point where the x-coordinate is 0 and the y-coordinate is a number, that is going to give you your y-intercept. Okay? So when I combine these, I have y is equal to, the slope this time is -4, multiplied by x, plus the y-intercept, which is positive 4. Look at that. Piece of cake. We're almost done. We're going to do one more example. You might also be asked to write an equation for a linear function. Remember, linear functions are just like equations, okay? So don't get tripped up by that word function. We're going to kind of do the same thought process. This time, we're given the values. The function of 0 is equal to 5, and the function when I plug in 4 is equal to 17. So I would say first what I would do is maybe just clarify what each of these mean. So the function of 0 when it's equal to 5 is really telling you this coordinate, 0, 5. And same with the function of 4 when it's equal to 17 is really giving you the coordinate 4, 17. Well, with that information, I can easily find the slope, right? So the slope would be y2 minus y1 divided by x2 minus x1. So let's do this. 17 minus 5 divided by 4 minus 0 is 12 divided by 4, which is 3. There we go. And then I also see, oh, my y-intercept. I don't even have a graph. But I can see from this point right here, the 0, 5, that the y-intercept is going to be at positive 5. So when I combine these as a regular equation, it would be y is equal to 3x plus 5. The only thing that you need to change when you write it as a function is instead of saying y, we're going to say f of x is equal to 3x plus 5. And I'm done. So I'm going to give you one of these to do on your own, and then when you come back to class, we'll just check to see how you're doing and get to work. So it says, on your own, write an equation for the linear function f with the values f of 0 is equal to 3 and f of -4 is equal to 11. And so I'll see you in class tomorrow.